Today, we will learn about 5 laws of exponents. In the previous video, we learned that a number such as 64 in its exponential form can be expressed as 4 to the power of 3, where 4 is the base and the number 3 is the exponent. This form can be read as the third power of 4. Do you know that by using this form, we can perform big mathematical operations within seconds? However, for this, we must know the laws of exponents very well. So let's understand these laws. Let us learn about the law of multiplication of powers that have the same base. Suppose we have to multiply two equal base powers, such as 4 square into 4 cube. Can you tell us how to do it? Think of it. You are absolutely correct. To find the values of 4 square, we will multiply 4 by itself 2 times. Similarly, to find the value of 4 cube, we will multiply 4 by itself 3 times. Now you can see here that 4 multiplied by itself for a total of 2 plus 3, that is 5 times. Therefore, we can represent it as 4 to the power of 5. Now you can see that the base of the numbers multiplied is equal to the base of the result, and the sum of the exponents of the numbers to be multiplied is equal to the exponent of the result. Let's take another example. We can write minus 4 to the power of 5 into minus 4 to the power of 3 is equal to minus 4 to the power of 8. Here also, you can see that the sum of the exponents of the numbers to be multiplied is equal to the exponent of the result. Based on these examples, can you make a comprehensive rule for multiplying the powers of the same base? Think a little. You are absolutely correct. We can say that for a non-zero integer a and whole numbers m and n, a to the power of m into a to the power of n is equal to a to the power of m plus n. This means that if there is an exponent in the numbers to be multiplied, then we will add all the powers and write the result as the power of the base. Now let us learn about the rule for dividing numbers with powers having the same base. Let us simplify 6 to the power 5 divided by 6 to the power 3. These can be represented in the form of numerator and denominator. 6 to the power of 5 is 6 multiplied by itself 5 times, and 6 to the power of 3 is 6 multiplied by itself 3 times. Upon solving, we get 6 into 6, which is equal to 6 square. If we look at the numbers and the result to be divided, it can be understood that the power of the result is the result of the subtraction of the power of the numbers to be divided. Let's see another example. We can simplify minus 8 to the power of 7 divided by minus 8 to the power of 2 this way. This gives the result minus 8 to the power of 5. Therefore, broadly we can say that for a non-zero integer a and whole numbers m and n, a to the power of m divided by a to the power of n is equal to a to the power of m minus n, where m is greater than n. That is, if the base is the same for division, then the power of the dividend can be reduced from the power of the divisor, and the obtained quotient is written as the power of the base. Can we take the power of a power? Let's find out. Solve 4 square into 4 square into 4 square. According to the law of exponents, during multiplication, the power of the numbers having the same base can be written as 4 to the power of 2 plus 2 plus 2, which is equal to 4 to the power of 6. But if we look closely, 4 square has been repeated 3 times, which is why we can write it as 4 square to the power of 3. Therefore, we can say that 4 square to the power of 3 is equal to 4 to the power of 6. Now the base is the same. Can you determine the relation between the exponents? Think a little. Absolutely correct. Here, it will be 2 into 3 is equal to 6. Therefore, we can broadly say that a non-zero integer a and whole numbers m and n, a to the power of m to the power of n, which is equal to a to the power of mn. When the power of power is given, then we multiply all the powers and express the result as the exponent of the base. By this rule, verify minus 5 to the power of 3 to the power of 4 is equal to minus 5 to the power of 12. Now let's understand how to multiply base having the same power. Suppose we have to simplify 2 into 5 to the power of 3. Since the power is 3, we will multiply 2 into 5 3 times by itself. For multiplication, we can either use commutative property or associative property so as to change the order and set of numbers. So, we will define the numbers in this way. Here, 2 is multiplied by itself 3 times, so we can represent it as 2 to the power of 3. In the same way, we can represent 5 as 5 to the power of 3. Now, by looking at right-hand side and left-hand side, we can say that if a and b are both non-zero integers and m is a whole number, then the expression a multiplied by b, whose raised to the power m, can be written as a raised to the power m multiplied by b raised to the power m. That is, the combined power for multiplication is the power of each term separately. We can also say that the power of brackets is the power of all the terms written inside. With this understanding, will you be able to formulate a rule for the division of base with same power? Pause the video and practice. Let's understand this. Suppose we have to simplify 2 by 5 to the power of 3. Here, 2 by 5 to the power of 3 can be written as 2 by 5 into 2 by 5 into 2 by 5. We can also write this as 2 into 2 into 2 divided by 5 into 5 into 5, which can be written as 2 to the power of 3 divided by 5 to the power of 3 in exponential form. We can say that 2 by 5 to the power of 3 is equal to 2 to the power of 3 divided by 5 to the power of 3. Broadly, if both a and b are non-zero integers and m is a whole number, then the expression a divided by b the whole raised to the power of m can be written as a raised to the power of m divided by b raised to the power of m. A to the power of m divided by b to the power of m is equal to a by b to the power of m. Here also we can say that the power of the brackets is the power of all the terms written inside. Here we have shown all the laws. Pause the video and read them once. So today we learned the 5 laws of exponents. In the next video, we will get to know them better with the help of some examples.